Live from New York, it's Ask an Engineer.
Hey everybody, we're back. You thought you were rid of us, but no, we can't be kept down. We can't be held back. We can't be crushed underfoot. It's me.
First they ignored us, then they fought us, then they made fun of us, then they reply guy you. And then we show up.
It's me, Lady Ada, with me, Mr. Lady Ada, also known as the comedic relief. We're back hosting Ask Engineer. Last week was super nutty,
Yeah, got
but
a
it's
lot
all
going
good.
on.
Yeah.
We're yeah, just to give everyone a heads up, we're having some of our remote team who haven't visited in a while because there was COVID and everything going on, hard to coordinate a bunch of people. So we had everyone in town, so we just had to shift some things around. We did show and tell. We'll have some of the segments from last week's uh, Ask an Engineer on this show, and then we have a couple catch-up segments we do. And then we had Deskofladyada, and we'll talk about that during this week's show and more. Speaking of, let's kick it off.
What's the code, Mr. Lady Ada?
The code is HUSB husb.
Husb.
Yeah,
You're my husband.
yeah, husb. It's 10% off the Adafruit store all the way up to 10:59 p.m. tonight. Use it or lose it. Save a buck or two. We'll also talk about some of the free stuff. We'll talk about some of our live shows, including Show and Tell. We just had Show and Tell a few seconds ago. Desk of Lady Ada. We'll have a bit of recap, including the Great Search. We have JP's product pick of the week, some time travel news, and more going on. We have some advanced manufacturing, New York City factory footage. We've got some 3D printing. We have 4 videos altogether tonight because we're catching up from last week. We have some Ion and PI. This week is Texas Instruments, of course, brought to you by DigiKey. We've got some top secrets, some things we wanted to show last week, but we're going to show them this week. New products. We'll answer your questions. We do that on Discord, adafruit.it/Discord. Go there. That's where we coordinate all of the questions and more because we're broadcasting all over the place every single week in some way, shape, or form. All that and more on, you guessed it, Ask an Engineer.
That's us.
Okay, so for the code, it's HUSB. Use it, you get free stuff. What does it get, Lady Ada?
Our freebies are enabled and in action. We've got a new crop of freebies. $99 or more, you get this beautiful PCB coaster with a gold Adafruit logo. Comes with bumpers too. I use them around the house. It's great to have coasters, and if you order more than a couple times a year, you'll get multiple coasters to complete your set. 149 or more, we still have the KB 2040 all-in-one dev board for use with the RP2040 chip. It's Pro Micro Pinout compatible. It's got tons of memory, RP2040 chip, buttons, NeoPixel, STEMI QT port. It's a great beginner microcontroller board. Free UPS ground shipping orders $200 or more. We still have UPS and we have better rates than ever, which means it's even easier for us to offer free shipping when you order $200 on the Adafruit shop.
That's right.
And then last but not least, we are still doing our promotion with NXP and DigiKey and us. It's a trifecta of goodness, a triangle of wonderfulness. It's the IMX RT 1011 with micro SD card Metro. A great way to get started with an amazing crossover processor that gives you 500 megahertz of Cortex M0 deliciousness, 120K of RAM, 8 megabytes of QSPI flash, and a built-in micro SD card. And with CircuitPython support, it's so speedy. It's a really roomy processor you can use with various Arduino shields, or just if you want to experiment with Python on microcontrollers.
Yeah, and don't forget all that stuff works with the discount code HUSB. Okay, we did a bunch of live shows over the last week or so. So to catch you up, the first one we'll talk about is Show and Tell. So Show and Tell,
Just 2
Scott
weeks
talked
ago.
about, yeah, well, what? Yeah. So this week's on Show and Tell, Scott showed some latest updates for some CircuitPython stuff. Where
Yeah.
the expressive, what is it, the idea?
He's doing the IDF 5.0 and 5.1 update to CircuitPython. So he's adding more chips such as the C6, which he demonstrated.
Yep. And then Jepler had a really cool keyboard with
the
Pico inside of it.
Model M, it's like a buckling spring keyboard, and they actually ship with an RP2040 Pico inside it, which means running CircuitPython and it's super easy.
Out of the box, essentially. And then JP came by, a lot of neat synth and music stuff, showed a little app that you can do things with. It was called Feud Machine.
Fugue Machine. Fugue Machine. Yes, guess what you thought? Oh, I thought we could...
Yeah, name of a band. feud machine.
Lauren had her cool necklace.
Yeah, which
Yeah,
was the see, we're going to show that.
It's a guide.
It's a guide, and we have a video that we're going to show this week. And then we also had Anne. Anne was showing off some of the latest and greatest with the like little Star Trek capacitive
Touch thing, yeah.
touch thing, which is cool. And then Paul came by with this neat Python library that does Shazam, so it gets the sound, the song, and then it displays it.
Yeah.
And then
they publish his code too.
And then DJ Devin had like a little square of like the Vegas sphere.
Yeah.
It was a cool,
a really big display.
It was a really neat thing. We were talking about this in the 1 minute between the show. It's pretty amazing that you can have a matrix display that's driven by a microcontroller now that's like low cost. This used to be really hard, expensive, and impossible.
It used to be you need a full Windows computer, did not run anything on, or you could use other computers, but you have an HDMI receiver card and then a transmitter card.
It was really tough to do.
It was like $500 for the cards, and then like it was to program it, you'd have to write your code and have it on your Windows machine. Now it's standalone, and runs on an ESP32.
Yeah. So moving right along. And don't forget, show and tells every week, 7:30 p.m. Eastern time, every Wednesday. On Sunday, we did Desk of Lady Ada because we were catching up on things and we're showing off stuff. What was part one of your desk?
Okay, well, first off, I was showing off the new 2.4-inch TFT Featherwing, which I'm slowly trying to bring out of retirement. We also showed off a Max 3421E support in TD-USB. It's got merged in, which means that I can resuscitate this very old Featherwing design for the Max 3421. There's Arduino library, but I really wanted TD-USB support, so it would work with Arduino or CircuitPython. And then, of course, the HUSB, which we have in the store today, which is why that's the code.
Then we do Desk of Lady Ada. This is brought to you by DigiKey, partner with this, and it gets you the things you're looking for on digikey.com. What did you hope people find?
Yes. Okay, so on the great search this week, we had somebody, because a few weeks ago we covered SWD ports, 2x5 connectors that go on our Feathers or Metros. And somebody's like, hey, is there like a low profile way or a smaller pin version of this? And I was like, oh yeah, it's called Tag Connect. It's very common. So I wanted to show off Tag Connects available at DigiKey. You can get a variety of cables and contacts. And it's this is a more, not I want to say proprietary, but it is, you can only really get Tag Connect connectors from this one company. I believe they have a patent on the design. But there's also if you don't want to use Tag Connect, there is a way of doing it with SCED connectors. There was a tweet by Arturo182 and then another person whose name I can't recall, showing off that the Worth Electronics SCED connector is a press fit connector that's I think 0.1 inch spacing, and it also has this press fit capability. And so if you want to use a non-Tag Connect version of a similar connector, this is an interesting version that you can use for any other press fit needs as well. So it was a twofer.
Okay. And then we have JP's product pick of the week. We're not going to do the week before. We're going to do this week's. This is when JP shows you something from the product page. The discount's automatically applied. Here's this week's highlight.
It is the QT Py ESP32S3. This is the version that has 4 megabytes of flash and 2 megabytes of PS RAM. You can do so much on this. Use CircuitPython, use Arduino. It's got the Wi-Fi built in. This has native USB. I've got my QT Py right there. I have the iSpy BFF there that allows me to plug in an SPI display. Look how quick this thing boots up. I'm gonna go ahead and plug that in and boom, up and running. ESP Wi-Fi Analyzer. This thing will check the local SSIDs in its area based on the little tiny antenna it has on there and give you a display that tells you about the strength of the Wi-Fi signals that you're seeing. That right there, that is the ESP32S3 QT Py with 4 megs of flash and 2 megs of PS RAM.
Get JP's workshop is tomorrow, and then Friday. Sometimes it's in time, sometimes it's Scott. This week it is Scott Deep Dive with Scott. Fridays at 2 p.m. Pacific, 5 p.m. Eastern. Learn about all the innards of CircuitPython. and more.
Gonna go
Let's do some time travel.
Gonna go back in
Got
time.
a little
Gonna go
updates,
back in
reminders, and more. First up, we've took the week off for PCB of the day, so we've got so many.
And you got like 650 PCBs.
We've got a lot. So some weeks we try to do a PCB of the day, every day. Some days it's like once a week or whatever. But you can check out these little vignettes and movies and stuff that we have. We're experimenting with voiceover. It's not AI. Lemore is just a good enunciator. And so you might hear the voice of Lady Ada talk about what the PCB of the day is. Anytime we use those AI tools, we let everyone know. I don't like the robotic voice, so I don't think we're going to do the text to speech with the robot voice. I think we're going to do. We have a workflow. The other thing is this is nice for accessibility because someone could just listen to it and hear some of the things that you can do with whatever chip or whatever thing
Yeah.
it is working on. Okay, let's do some Python on microcontrollers. Okay, first up, before we even jump into the newsletter, we want to say happy trails and more to Kattni. It's not goodbye. I was saying in our meeting, it's like, I'll see you on the other server instances. Kattni is the one who came up with Code Plus Community, has been in the CircuitPython community, doing a ton of stuff with Adafruit, getting us this.
In the Discords.
Yeah,
forums.
on GitHub, on the Learn Guides.
At PyCon.
So Kattni's not going to be doing stuff with Adafruit, but still in the community, still doing stuff in the world. I'm sure you'll see all those things Kattni's up to. But we wanted to say thank you so much for everything you've done, Kattni. We're rooting for you and all the things, and I'm glad Adafruit was a stop along an awesome journey. Thank you so much. Yeah. And everyone in the Discord, I think Kattni's in here.
Send your shout outs.
Please send your shout outs, and we call them hug reports and more. A lot of folks got their introduction to Adafruit via Kattni.
That's right.
So, and they're doing stuff. So that's what it is to be a community. Thank you, thank you, thank you, thank you, thank you. So let's do some newsletter stuff. I'm going to ask Lady Ada some questions in a moment. But first, the CircuitPython 826 release is out. It's basically just like certificate stuff.
Yeah.
But you can check that out if you're interested. Lady Ada did an interview on PyCast, and this was a pre-record because it was really hard to find time. So they did a pre-record, and Lemore steps through the library creation using ChatGPT 4.
Yes.
So far, it's interesting. It seems like we've I think someone had to go first and say, like, here's how we use these tools and here's how we're going to show our work. So we post the full prompt logs as Lady Ada interacts with it, and we put that as part of the README in the GitHub repository for our open source libraries. And we also disclose all of the stuff if and when we use any type of AI tool. These things are here to stay, so we thought, well, what's the best possible way to show that we're doing this? If we use things like even Copilot, we'll say it, but we think that's the best way to do it.
Yeah. I posted my my log with OpenAI, and other people said that they actually enjoyed that because they could learn how I like people one of the questions in the Pi chat they asked was like, how did you know this is the prompt to use? And I was like, well, I didn't. Like, it took a couple tries, guys. Like, it was like night number 3 where I was like, wait, I finally got the right prompt to get it to write the code from the data sheets. And so I chat about that and licensing. Like, how do you feel about it being able to imitate you? And I'm like, I think that's great for me.
We're in a unique situation, and I get that's why I think folks were scared, because there's like a big gap between like it's the worst thing or it's the best thing, and there's nobody really in the middle talking about like, well, all bits of technology you can use it for bad stuff, and there's crediting and there's sourcing, but in our particular case, the code that Lemore's using is Lemore's code.
Yeah.
She's just interacting with it with this large language model, which is kind of an interesting use case. There's probably not a lot of people doing it. The best analogy I can think of, only because this is probably going to be in the news, is like, so an author who has their stuff somehow in these large language models, having it be like a writing partner in some way, or like an assistant in some way. So human plus AI powered things. So we'll see how it goes, but you can watch the whole thing. It's on now. But the thing I was going to ask you is IEEE, they do their top programming languages each year.
Yeah.
And Python continues to, pop to the top. And it's usually because of, data sciences. Now it is because, or at least in part, people are using it for microcontrollers or things like Raspberry Pi. But what's the, I'll do five. What's the five programming languages you use on a regular basis, if there is five, and what do you use them for? Because I feel like you're the poster child for, engineering and programming in a lot of ways. So what are you using and what are you using it for?
Yeah, it's funny as I'm looking at these little arrows and they're like SQL. I'm like, why do SQL? I do use it, almost every day, but I don't know language. But I guess it's NP complete, huh? Or not NP complete. It's Turing complete. So for electronics and the kind of work I do, like I use Python a lot. I use it on desktop and I use it on microcontrollers. I use Arduino, which is C++. We do use assembly once in a while, not as much anymore, but I do use it. And JavaScript, we have also JavaScript for my controllers and then TypeScript with device script that recently came out. The bulk of it is, Python and C++, and then maybe a little smattering of assembly.
That's what you're doing right now.
That's the most of it, yeah.
And then for some of these like things that you're like gluing data together for like web stuff, is that also Python?
Python, a lot of it.
So like database or data source manipulation.
Yeah, like ironically, like I'm doing I do SQL every day because I'm kind of like doing some data analysis stuff on the Adafruit, manufacturing production management side. And I could write queries in SQL to do it, but honestly, I just have the Python iterate through it, and like, instead of trying to like left join and get that right. And I've been using ChatGPT to try to write better queries, but honestly, I use Python to like iteratively determine stuff. And then we were doing the open source hardware.
Yeah,
data
that was helpful
analysis
for
one, that
me.
was Python too.
Yeah, that was helpful for me because I was gonna try to go another way, and instead I used OpenAI's ChatGPT's code tool, and I explored a JSON file, kind of asking natural language things. I looked at the Python that it was generating to make sure it was like what I wanted. But what's interesting is it I wanted to know when it thought we would get to a certain amount of open hardware certifications, but because it doesn't really know other than the dates of the certification, which are actually when they're approved, it's hard to like, oh, linear regression, well, this is the way to do it. But we're beating its estimate. It's just because Lemore is doing a lot of hardware revision. So that was kind of cool. Okay. So thanks for entertaining my question. I figured I would ask an engineer. What languages are you actually using right now? Right now, well, as of right now, the number one certified open source hardware company in the world. We have 695 certifications.
Right, well,
we're not gonna always be. Maybe we'll always be the top certified company doing releasing designs. But right now we are.
Yeah.
So 695. We're very close to 700. So I thought this would be a good tie-in. Like, okay, this is what you're producing. What are the programming languages you're actually using? And it looks like a lot of Python and a lot of C.
I write scripts for EagleCAD, and that's also in C, which is kind of funny.
Okay.
C like, yeah.
Okay.
It's interesting.
All right, so we're getting close. If you want, you can sign up, get this delivered to your inbox every single week on adafruitdaily.com. Let's speaking of open source hardware, we have a bunch of guides, tons of them. Lady Ada, what's on big board this week?
Ooh, so many guides. Okay, so new guide from Noe, Pedro, and Liz of the synth guitar with CircuitPython Synth.io. So this is a remake of one of the first projects they did.
Yeah.
I've been sort of saying like, hey, now's a great time with the prop maker feather, especially a lot of projects that we can remake. So let's remake them. So taking a break from, we're going to do new stuff, but we're doing a bunch of remakes. So check that out. There'll be a video for it next week, but you can take a look at the guide if you'd like to look now. It's got like 8, Cherry MX compatible keys with RG backlights and like 3 encoders to change settings, a built-in speaker. It's pretty sweet. We also have Kattni wrapped up the guide for the Metro M7 with micro SD. That's that giveaway board we're doing.
Yeah.
Aaron did a little mini guide on making scannable links for Linktree or Venmo or PayPal
We'll show the
with
video.
NFC. We'll show the video. Have a couple guide updates.
Yeah, and these are ones that you can catch up from
and then
last
the
week.
scenario fundamentals.
Yeah, and the Tombstone prop maker.
So prop maker and the 2.8-inch touch shield that was updated because now we have the new version. So a bunch of guide updates and a few new ones as well.
Yeah, and we're gonna show the video from Aaron in just a second, but I did want to mention that we also have Playground. We don't know what we're gonna call these. These might be like poster show and tells in the playground, but these are guides that anyone can write.
Like I wrote this one and I'm also an author on Learn, but anyone can make guides that appear on
So
Playground.
this is teaching our kid different language with some kids books. And so so everyone kept asking, I really like the Learn system. Can I make guides there? And one of the things we don't want to do is it's not a ding on like Hackster or Instructables. We don't want to turn our site into a contest site or have like interstitials or you have to log in to see the whole thing or there's ads everywhere. We wanted just to have like the best place to author. So we're releasing the authoring tool for Learn in a very one step at a time way. So you can make the same type of guides that we have on learn.adafruit.com, but you don't have to be an official guide writer. You get to do that yourself. We're calling it Playground. These are like show and tells, and these are just like fast, lightweight ways.
They're just single page notes that you can make, and you can make as many as you want. Stuff that doesn't really fit in the learning system.
Yeah,
Some
it's like
text, some images.
Here's storage boxes. Here's 3D Hangouts this week. By the way, we respect do not track. That's why.
Yeah, that's why it doesn't show up.
Yeah.
Exactly.
So I always get asked like, why does it have that on the site? It's like, yeah, we actually do that. So you can check this out. It's a very quick, easy way, and anyone can start to do it.
Yeah, and like I wanted to when I sent you the links, we'll post later. As I do want to, I will promise, and you can always link to this video that there will not be interstitial ads. There will not be pop-ups. There will not be toast. There will not be sign in to see more. There will not be that annoying fade out where you're like reading and it's like to see the rest of the article.
You scroll and like the text drops off and it's So
we're not going to do that.
Yeah, and the reason why we're not going to do that is because we have a business model which is like buy some hardware, buy some electronics from us. That's the best way to support us. And it's open source.
Yeah.
So and a lot of the people who work for us. We pay them.
We'll never have a thing that says donate $2 or Jimmy Wells is gonna die. Like, I'm not.
Yeah, we're just doing something a little different.
It's different. It's okay. They can do that. It's cool.
Yeah. Is there money being left on the table? Yes, but we don't want to monetize all of y'all with your personal data in any way. So that's what we're doing.
Have your ad blocker on or have it off.
Don't matter.
And I won't have the thing. I hate the thing that's like you have an ad blocker. It's like, yeah, I do.
Yeah.
Because it's impossible to use your site without one.
Yeah, we don't want to track you and do any of those things.
No.
All we want to do is serve the great content that folks are writing.
Anyways, this is my promise.
That's what we're doing. Yeah.
No Christmas trees. No sign up to see content.
Yeah. All right, let's play Aaron's video.
For today's project, we're using NFC tags to create scannable business cards and tap-to-pay Venmo links. Use the free NFC Tools app to program your tag. You can program it to launch any URL on an iPhone or Android smartphone. I programmed mine with my Linktree info, so new friends can follow me on any of my social media links. These tags are small and light enough to hide just about anywhere on your outfit. Connecting just got a lot easier. Just tap any NFC-enabled smartphone to the tag and watch the magic happen. You can also create tap-to-pay Venmo links to make money transfers a breeze. See a full build tutorial at learn.adafruit.com and remember to click that subscribe button for more fun projects.
All right, let's do some factory footage. That's factory footage. We're going to do some 3D printing, and we're doing some ketchup and mustard and mayonnaise.
Onions.
So we're going to play these videos back to back.
Okay.
There's the tombstone video, this glowing thing, and then a Halloween overview. So let's play them on. We'll see you on the other side.
Okay, I'll see you soon.
You can build an interactive tombstone for Halloween with Adafruit's RP2040 Prop Maker Feather.
Happy Halloween!
This ghoulish prop features an RGB LED matrix, neopixels, sound effects, and a servo-controlled raven. It uses a time-of-flight sensor to detect whenever someone gets close and triggers the sound effects, the servo, and neopixels.
I smell children.
The RGB LED matrix displays a scrolling message to warn or welcome would-be trick-or-treaters. The tombstone is an off-the-shelf styrofoam prop. It's easy to work with, so we were able to cut out channels and recesses for the wires and electronics. The RP2040 Prop Maker Feather does most of the work, and the Matrix Feather Wing makes it easy to plug in an RGB LED matrix. CircuitPython has built-in support for RGB matrices using the Display I/O library. The code features adjustable parameters, so you can customize just about every attribute in this project. You can get the parts to build this project, links are in the description. The Raven is 3D printed and hollow for fitting the servo and neopixels. The time-of-flight sensor breakout has a protective sticker over the sensor that'll need to be removed. The Matrix Feather Wing is set up with headers for plugging onto the bottom of the RP2040 Prop Maker Feather. The two can then be plugged into the Hub 75 socket on the back of the RGB LED matrix. A hot wire foam cutter is used to create the opening for the RGB matrix display, and a piece of black LED acrylic diffuses the LEDs. The two NeoPixel buttons are wired together for adding a glowing effect to the demon atop the tombstone. The eyes are then carved out for the LEDs to shine through. A speaker is fitted into another recess with a press-fit cover to keep it in place. The time-of-flight breakout also has an opening for the sensor with an accompanying back cover. A piece of foam core is secured to a servo horn that press-fits into the head of the 3D printed Raven. An additional set of NeoPixels are wired together and fitted onto another piece of foam core with a cutout to secure the servo motor. The Raven's head is then press-fitted onto the piece of foam core. Additional extension cables are used for the servo motor and NeoPixels. Pieces of black conduit is used to help keep the wires bundled together and hidden. The Feather's onboard STEMMA QT port and screw block terminals make it easy to connect the various components. Everything gets powered by a 5V 4A switching power supply so it can haunt all night. We had a lot of fun building this project and hope it inspires you to check out Adafruit's RP2040 Prop Maker Feather and CircuitPython.
And that's the Halloween inspiration.
Spookalicious.
You have plenty of time to start on your Halloween projects, either for this year or next. It's fine. It totally works. Little bit of a break. Don't forget the code is HUSB. Let's do some INMPI.
Okay.
INMPI brought to you by DigiKey. Thank you, DigiKey. And this week it's Texas Instruments. Lady Ada, what is the new product introduction of the week this week?
Okay, this week we are back with a classic TI. They make such cool stuff, and we're going to be looking at their TMUX series of analog switches. They come in TSOP. They also come in QFN, but this is the icon they've got on the DigiKey site. So the TMUX 821 series is SPST analog switches. They are fully solid state, not the same as a relay or even a solid state relay. These are analog switches that are meant to pass analog signal back and forth, but they're much, much faster than relays. They don't have a mechanical situation. They don't click and they don't get oxidation. They're definitely a lot smaller and less expensive than solid state relays. You saw the package is just like a 16 or 18 TSOP. Goes on your board and it can switch bidirectionally signals that can go up to 100 volts, which is very high. This is a particularly high voltage analog switch. And then you can control the switch open or close with logic levels way below 100 volts. It goes down to 1.8 volts. So let's take a look at what we've got here. So you are familiar with your standard push button switches. You want to connect analog signal back and forth. You can use a push button switch or a slide switch, toggle switch. DigiKey has tons of those. If you don't mind, having a mechanical connection, these work really great. You want to switch audio signals from headphone to speaker, and you don't mind having a button or a switch, go for it. We'll do the job quite well. And there's hundreds and hundreds of thousands of options as well. This is just the push button switches, but for toggles and slide switches, there's also a ton of options. But these are mechanical switches, and so somebody has to mechanically press the button or flip a switch. Like I said, you can use a relay, but relays are really, really big, and they're loud and clicky. And they do fail after a while because they eventually oxidize. And so an analog switch is kind of like a mysterious and mystical thing. It acts just like your everyday normal mechanical switch, except that the thing that connects or disconnects is a signal, a digital signal. In this case, they are implemented by having two back-to-back NFET and PFETs. And, by manufacturing this on your silicon and doing a good job with the isolation and the specifications, you can have it be a bidirectional switch. So signal can go back and forth between the two sides. So, which is interesting. Most people think of, a FET switch, a PFET or NFET switch as sort of a unidirectional. You want to send, connect a source voltage to a a source voltage to a sinking load. You can do that with a switch. But in this case, you actually have, true analog bidirectional communication. And in this case, it even goes at a much, it can go at a fairly high voltage, 100 volts of common mode between the two. One nice thing about having analog switches is you don't get switch bounce. So like I mentioned, relays are often used in such situations, but especially for telecom, but you will get chatter, you're going to get oxidation, and they will fail eventually. Whereas what's nice about these analog switches is you don't have, when they switch, they switch on pretty much instantaneously. So you can switch back and forth multiple times after worrying about oxidation or switch failure. But there are some downsides. So one downside is that when you're dealing with a mechanical switch, when it's closed versus open, it's basically either a short, like almost 0 ohms, 0.001 ohms or so. And when it's open, it's infinite ohms. There's no connection between the two contacts. When you're dealing with a analog switch, there's always going to be some resistance. So when it's closed, it's not zero resistance or even 0.001. it's 5 ohms, which is like not a small amount. And in this case, it is also, yeah, I think it's like 7 to 10 ohms. You can get very low R-on analog switches. This one is medium. I did compare this with the CD4066, a common low-cost analog switch, and that was like 120 ohms. So this isn't too bad, 5 ohms or so. And when it's open, it's not truly open. You do have some leakage between the two. In this case, it's 10 mega ohms, for example. You can find the specifications for what the actual on and off resistances are in the data sheet. In this case, the on resistance is, it's about 5 to 10 ohms, depending on the temperature. It is pretty consistent, like you're not going to get a high variation with temperature, which is kind of nice. Some switches, make sure you check the spec sheet with temperature and voltage. The specified resistance on the front page of the data sheet may go up quite a bit. And then you can see the drain off leakage. So that's how much current will leak between the A and B contacts. Another thing to watch out for with analog switches is you do have to, it seems obvious in hindsight, but if you have a mechanical switch, the voltage that you use to turn on off, say, the relay, does not relate to the voltage that you're switching. You can turn on and off the relay with 3 volts, and then when you're switching, the voltage you're using to turn on and off the relay can be like 3 to 5 volts, and the voltage it's switching can be up to like 220 volts AC. In this case, you do have to provide with these analog solid state switches a plus and minus voltage that covers the total voltage that you're planning to have on the A and B pins. So, for example, you want to switch a voltage, analog voltage that can go as high as plus minus 12 volts. You'll have to provide VDD with 12 volts and VSS with negative 12 volts. So you'll have to cover that total voltage because you have to have your MOSFETs conduct. So watch out for that. Don't assume like, oh, my logic level is 1.8 volts, so I'm going to give it 1.8 volt for the VDD. No, it has to be as high as the highest voltage you're planning to put through the analog switch. Okay, next up, they are not isolated. It seems kind of obvious, but compared again to relays or switches where you have some physical space or plastic between you and the voltage, that's not going to happen here. It's all on one chip. So you could get a separate digital isolator. I just quickly looked up on ti.com and this came up. There's silicon and opto isolating. Either will work just great. But there are some nice things that are, like I wanted to give you the downsides of like, hey, watch out for these things. I have definitely been bit by some of them. But some of the good things are, I like little details, like they have the built-in pull-down resistor, so they're automatically enabled or disabled by default. There's a nice fail-safe, so that if you apply voltage to the selection pins, and for some reason the voltages aren't on the power pins, you won't blow up your chip. I have absolutely done that. So kind of nice to see that. There's also designed for latch up immunity, which is going to be very handy. You do not want your switches to latch. Like I said, the pull down resistors are built in, and you can run them off of very low logic. Sometimes the logic used to switch has to be similar to the voltages that are the highest and lowest VDD and VSS. In this case, you can just use your normal microcontroller voltage, but you can also go up to 48 volts. So if you are using a microcontroller, if you're using some signal coming in from your product or project, you might be able to use the working voltage if it's like 24 or 48 volts. There's 3 variations, the 8211, 8212, 8213. The only difference, the pinouts are the same. The only difference is whether they're normally connected, normally open, or alternating normally open and normally connected. And they're in stock right now, all 3 versions. So, and lots of them in stock too, which is kind of nice. Sometimes I'm like, no, there's only 2, and they sell out. But in this case, very handy, really useful, often for audio, video. I don't know if this would be necessarily good for USB. You should check whether the high-speed rating would be useful for it. But definitely AV switching, analog switches, or test equipment. You want to connect like different voltages around. Not good for switching big power supplies, but I think you do about 200 milliamps.
And that's this week's item of PI.
On PI.
We're gonna roll right into new products.
New. It's time for new.
What's new?
Coming soon, the AD5693, we've had requests for more bits on the DAX. People are always emailing you. You know that email you get every day? Where's my 60-bit DAC?
Bits on the deck?
Where's the bits on that? More bits. We have a 12-bit DAC. Now we have a 16-bit DAC coming soon, but we got some photos taken.
Okay, and then we have some round displays that are coming soon. These are going to go fast to sign up.
Ooh, they're in stock, but we don't have the driver board. But I did want to mention that if you wanted to pick these up, I will mention again that the connector used is not the standard 40-pin connector for TFTs, but our upcoming Qualia S3 board is going to plug into the
Yeah,
nice.
maybe buy it and then just hang on to it for a couple weeks. Then we'll have the boards for it.
Maybe we'll go to the overhead real fast and I can just show that what this goes with. So
Yeah,
you need a special board to drive these with in this
Really?
case. Which is coming soon. These like hot off the press, so they're not in the store yet. But you'll be able to connect these.
Yes, we're trying to make it easy because there's companies that sell like interesting displays, but nothing works. The
Yeah.
code you get doesn't work, or it's just only that dim out.
Yeah.
So we're trying to make sure that folks have, something that they can build off of and have.
Yes.
So that's going to be the board. That's going to be the.
Yeah, it's gonna be the board. RGB 666. That's what these. I'm gonna call these RGB 666 because they're 18-bit color. So we've got both the capacitive and non-capacitive round touch. We'll have demos and videos for these soon, but just letting you see the scale.
Moving as fast as possible, so that's why you're seeing these things going to the store as coming soon, or in the store as we're getting the board to drive them.
Yes.
Okay. Next up.
Next up, there's a revision to the 3D hand sensor. So this is for gesture detection and motion. It's from Ultra Leaps. It's their new, I think 3DI is the model number. The new thing is it comes with a mount now instead of a tripod. So on the back, look at the third photo. Yeah, this multi-mount comes with it. So it's easier to attach to like a monitor or to the wall or to a table. Before it came with a tripod, probably was easier to accidentally have it fall off the table. Now it's like more mechanically secure.
Next up.
Next up, we've got some handy USB cables that have a display built into them. So if you stop here, you'll see this is a close-up. So this is a Android phone that's plugged into a wall adapter that is able to provide 7 watts of power. For USB-A, this is it's a USB-A to USB-C, so you're not going to get power delivery with a lot of wattage, although this cable can handle 66 watts. But if you might have quick charge, but for the most part, it's good for, your 5-volt, 1 to maybe 3 amp output current capability. This is useful because, a lot of times your phone or your device has maybe some special charging capability, but it has to match up with the charger that can provide that quick charge or USB power delivery. And you can't really tell how fast it's charging. Like you can see like it's charging or it's not, but you can't tell, is it doing a better job with this adapter or the other? And so what's nice about this is that it just shows you a number. The higher the number, the faster it's charging. So if you have multiple chargers around the house, use this, plug into all of them, and whichever one is giving you the highest number, that's the best match. There's nothing like a USB cable standard to come up with more standards that are all incompatible. So this is just another example, plugging into a power brick that can provide 7 watts, and then per laptop also. We'll also have a USB-C to C version of this cable, and that will, of course, be able to do much, much more power because USB-C can easily go up to 100 watts.
Okay, star of the show besides you, Lady Ada, our team, our customers, and the entire community that makes things go is
the USB 238. Yay! I've been working on this for a couple of years. It suffered from a silicon shortage, and now it's back. This is a really cool chip. So we like USB power delivery here. It's a great alternative to infinite DC power jacks in a bin, in your basement, or under your bed. Or, having USB-A cables that can only provide you with 5 volts, maybe 2 amps max. So USB power delivery for USB Type-C, and we have a guide all about it, can give you up to 20 volts and up to 3 or 5 amps, depending on whether the cable can handle it. And that's really great because a lot of times you have, say, like a monitor you were showing me, and it needed, 18 volts, 3 amps, and you're like, where am I going to find an 18-volt adapter? Well, if you have USB power delivery, it's easy. You have only one adapter, and that adapter can provide any voltages you need. So let's go to the overhead real fast, and I'll show power delivery, power supply. So this is a power delivery capable power supply. And you'll see here, I mean, it has a couple outlets. That's why you're like, why is there so many numbers? Because it can do 100, 120, and then this is an 18-watt adapter. So you see here on the USB-C, it's like, I can do up to 100 watts, 5 volts, 3 amps, 9 volts, 3 amps, 12 volts, 3 amps, 15 or 20, up to 5 amps. But you're like, how do I actually get that out? If you use a normal USB-C cable to your device, unless you know how to request those higher voltages, you'll always just get the 5 volts. So you need a chip that talks to, or firmware that talks to the PD source chip in here. You need the sync chip, talk to the source chip and say, hey, I want you to give me 20 volts. It's not going to give you 20 volts by default. It'll always give you 5 volts default, and you have to request the higher voltages. And that's where the HUSB comes in. So if you look at the top of this board, by default, you'll see there's a jumper that says 5 volts. If you cut that jumper and solder close the 9, 12, 15, or 18, or keep it open and it does 20, it'll automatically request from the power supply that voltage that you wanted. And on top of that, it also has a I2C interface that you can use. And we have a library written in Arduino that you can tell it, the chip, hey, what voltages are available? And then you can pick and choose, dynamically changing the voltage. So, your robot or your motor or whatever starts out and you're like, well, let's try 9 volts. And then at some point they're like, wait, I need even more power. You can boost it up to 15 or 20. And you can adjust back and forth based on what's available. So let's look at this demo I've got. So I've got here, let me do this. No, hold on. Live demo. It's live demo time. How do I rotate?
Sure, do.
I was going to have this be not upside down, but I think I can't. So I'm just going to hold this and do this.
There you go.
Okay.
Good enough. I want to focus.
Science. Okay.
Yeah.
So I've got here the HUSB, and this is plugged into one of these wall adapters I just showed off with the USB-C ports, and it can provide multiple voltages. And then I have here this is just an ESP feather. I just chose it because it has a nice display. It is communicating over I2C. I've got it wired up to I2C, and it's requesting different voltages. And then if I plug into here, if I plug into, sorry, I gotta read this. Okay, this is into ground. And I have my multimeter, and my multimeter is working. There you go. You can see that the voltage coming out is in fact going from 9, 12, 15 up to 20, and then it cycles back to 5. So you can dynamically, change whatever voltage you want. You request what's available, and then you can cycle through it. But if you don't want to use a microcontroller, you don't have to. So try unplugging this. If you, hold on, I have to reset this because it was just, it was just programmed over I2C. So by default, I have this jumper. You see, I tried every jumper setting. I have the 12-volt jumper set. And so by default, it will now give me 12 volts output. So you don't need a microcontroller. You do need to power cycle it if you just programmed it over I2C. But by default, it will go with what the jumper says. And then over I2C, you can set it to something else. So it's kind of the best of all worlds for USB PD. It's inexpensive. I've got this nice chunky pass transistor here. And set it with jumpers if you like, and it's fixed. You can solder in a terminal block if you like, or use I2C and you have, a more dynamic, customizable USB PD experience. So, either way. Also, you can use it with a microcontroller and not use the I2C. You can use it to get your voltage, and then, this could do some other work with the over USB, because I have the D- and D+ lines brought out here. So this could be your main connection for USB-C, and then this goes to your microcontroller. I just got to warn people, this V plus pin, don't forget, it can go up to 20 volts. So if you're using this to power your project, you need a regulator that can take up to 20 volts if you request it and bring it down to 3.3 or 5 volts. Okay.
And those new products.
A long description, but I think it was worth it.
Mm-hmm. Okay,
Okay.
don't forget the code is HUSB. We're going to do a little bit of top secret. You can post up your questions in the chat in Discord. Make sure it's in Discord. And if there's questions that come in later after we're out, don't worry, put them there. We're around. The community's around. But do make sure that you're doing it on Discord, adafruit.it/Discord. That's where we collect all the questions. So let's do a little bit top secret. While you do your questions in the chat, if there are, I'm going to do just a couple seconds of some of the videos that we were playing, and then I'll play the full one for the Star Trek animated series. So this is what we were doing during Star Trek Day for these displays. All right, Lady Ada, what is this?
Okay, well, in honor of Star Trek Day, we are playing all sorts of different Star Trek intro videos on this 480 by 480 TFT. And those are the specs for playing a 30 frame per second Cinepack, which, if people remember, was a file format that was used in games and I think DVD intro screens and a couple other use cases.
Yeah, that's good.
So it's Cinepack encoded into an AVI with MP3 as the audio format. And this is a way, I don't want to say.
Lady, what is this?
Spock, I'm playing video on an ESP32 S3. This is Moon on Our Nation, which is a matching username on GitHub, made a way to play videos by having an M.
Really, dude. That's what people wanted.
This might be some sort of thinking computer. So this is the fourth video we're doing with Star Trek Day, and this is the animated series and the Kazinti, which are evil and slightly goofy cat beings.
Yep. Cool. And that's top secret. That's what we were showing part of during Star Trek Day, and we were off last week, so I wanted to show some of those this week. Let's go to your questions.
Hit me.
Yeah, we got a couple lined up. Do this right away. Let me get us in the. Here we go. How do you decide if a product is worth making and how many units to make, especially early on when it's potentially a bigger decision? Do you just start hand assembling orders you receive? No.
No, I haven't hand assembled in a long time. I think the last time I hand assembled stuff was when we were doing the ADXL 335. I did hand assemble the first SMT boards that we sold. But I try to make about 250 pieces. I find that's a really good spot where it's like, you know, it's enough people that if there's issues, I'm going to find out about them really fast. But I'm also able to, you know, if it does work out, I think I have enough in stock to get them to people. I don't know how to explain it, but like 250 pieces.
Yeah, we also have prototypes that come in and our team tests and use. Often our team is working on guides or we're doing photography.
Yeah.
So we have a little bit of a cushion, but usually that seems to be the number of like, let's get some out in the market. If there's any revisions or iterations or anything that comes up, we can make different decisions. Might be different for different folks out there. You know, we have thousands of orders a day. So sometimes they go very fast and the folks are like, but I want to buy more. And we're like, the next batch is coming in, but that seems to be the amount. Little bit of a kudo.
Three protos, 250 boards.
Yeah. Kudos for you. An HUSB live demo with your explanatory chops.
Yes.
Deeply inspiring. Yeah, this is a cool product.
It's a very cool chip.
This is really neat.
But I want to guys to explain it all and then warn people like you're gonna blow up your thing if you just like it's not 5 volts anymore. It's not 20 volts.
Next up, what do you think the maximum number of matrix panels on the Matrix Portal S3 will drive? I'm up to 12, which is 6 more than I thought.
Actually Phil B did the math, and then I think we got super busy and I forgot to update the guides, but I think it is around 12. I think
you might be
your max
pushing up against
it's
the
not
max.
it's not the memory because you're using PS RAM, but it is the amount of dithering you can do before you like the screen starts looking kind of crummy because you can't dither fast enough.
Yeah. Okay. I think that's
Okay.
the questions for.
Okay.
All right. So I normally don't have sad news, but once in a while we do. This is about a person that y'all are probably familiar with. Tony DiColo worked with us at Adafruit 5-6 years ago. You might remember the series Watch Tony D's Desk. This is a series of videos and shows and live streams that we're preserving on YouTube, and also all of Tony's guides. Tony died a few weeks ago. I'll post up the obituary in the Discord chat. We've reached out to the family and we got some information, and we wanted to pay our respects and also dedicate this episode and also show everyone we're going to be keeping Tony's guides around and Tony's videos. I know that was important to Tony. Every memory I have of Tony, this is one of the photos I got of Lady Ada and Tony at Maker Faire. Always sharing, always in the community, always doing things. And I just wanted to share this news. We got this. We were devastated. We tried to find out this was, obviously a private family matter, but there is more information now, and it's now on a website that has the obituary. So I thought this would be the proper time and place to do this. Adafruit donated to the charities that the family said. This is the Washington Alpine Club. Tony was an avid mountain climber, and the Seattle International Film Festival. And I just wanted to send my thoughts to the family. And I know Tony impacted a lot of folks. He was doing a lot of stuff in the very early stages of us doing Python on hardware. People still review his videos and learn a lot.
He started the newsletter.
Started the newsletter with us.
Some of the first MicroPython guys.
And the Tony's legacy lives on here. But thank you to the team that got us this news and was able to send over more information, and I'll post that in the chat. But that's our show for tonight, and I just wanted to dedicate this to the memory of Tony.